Hi, good afternoon. We are Chicken Tinder, a team consisting of Lee, Talisa, Laura, Christoph and Jordan. Our app was aimed at a group of friends who can't decide on where to go for any social event, for dinner. That age-old argument, I fancy there, I ate there last week. We look to solve that. We look to take the restaurant repercussions out of restaurant roulette by making it more of a restaurant referendum. An app with a slick user interface and an algorithm to match to return a winner. With all that said, let's hand over to Talisa to show you swipe, match, eat.
Thanks, Lee. I will be taking you through the app. First, I will sign up using Firebase authentication with a dummy account. But for the purposes of the walkthrough, I will log out again and then sign into an existing account to create the event that we're going to work with. From my home page, I can now create an event for the team, and here I will be able to give it a name. We'll call it Chicken Tinder Launch Party, and then I'll be able to set my location, either using current location or using an autocomplete feature that makes use of Google Places library. Then I will invite my friends by selecting the checkboxes next to their name on the friends list. By selecting it once, I add them. By selecting it again, I will remove them from it. Once they've all been added, I can create the event, and Take Me to Event will then take me to the list of 10 restaurants generated by the app. My friends and I can then start voting, and the voting works that swiping right indicates a yes and swiping left indicates a no. Once everybody has finished swiping, as is demoed now, using a mix of Android and iOS devices, we will be able to get a match, our winning restaurant. So the restaurant that was most favored by everybody. Going into this to see the winner, you get the winning restaurant card, which shows you everything you need to know about the restaurant, giving you a description, the cuisine options, the type of cuisine, as well as their phone number, location, and a quick link to their website so you can book directly. I will now be handing off to Laura to talk about the front-end tech stack. Thanks.
Hi. As a team, we explored different options for building the front end of our app, such as React Native and Flutter, but we ultimately decided to go with React. We were all familiar with React from the Northcoders course and thought that the familiarity would be beneficial considering our short time frame for creating this app. Even though we were familiar with React, we challenged ourselves with other new technologies. On our backend, we use GraphQL. This will be discussed further shortly, but we needed a way to interact with this on the front end. This is where Apollo Client Provider came in. This facilitates the interactions with GraphQL and works seamlessly in React. Apollo Client is designed for modern React, and this enabled us to use up-to-date features such as React hooks and therefore the Apollo React hooks. Hooks were not a part of the curriculum at Northcoders, and this added an extra level of technical ability, but another learning opportunity as well. Our login and sign-up feature uses Firebase for authentication. Firebase is user-friendly and provides security straight out of the box. It also integrates nicely with React. Firebase generates its own unique ID, a UID, which provides a way for us to track logged-in users, but this came with its own issues, which will be discussed later. When creating an event in the app, location is an important parameter. A user has a couple of options to provide a location. We have an autocomplete feature that utilizes the Google Places library, so a user can pick a very specific location. This will allow them to plan for events that may be further away from home. For those events that might be staying closer to home, there is the ability to use their own location, which uses the HTML geolocation API alongside the Google Maps reverse geocoding ability so that it will output a readable address to the user. And it wouldn't be a Tinder-like app without swiping. For this, we used a very simple NPM package called React Tinder Card, which provided us with basic swiping actions. We were able to build on this to integrate it into our voting functionality by sending our votes to the backend depending on swipe direction. Finally, we use Material UI for styling our app. This was new to everyone on the team, but we all agreed that it was very user-friendly, easy to pick up, and the documentation was excellent. It can also work alongside existing CSS. It provided a great way to have multiple users apply styling to produce an app with a uniform and clean-looking design. I'll now hand you over to Christoph, who will talk about the backend.
Thanks for that. So on the back end, we definitely wanted to engage with some new technologies during this project to show that we're able to pick up new concepts and also use them straight away for building. One of them was around storage, so we wanted to explore non-relational databases. We settled on MongoDB, and we used MongoDB Atlas, which is their cloud-based storage service. It's very easy to administer and links well to the Node Express server that ultimately runs our app, backend app. Between storage and the server, we have Mongoose, a library that uses schemas to define data types, and it also is responsible for the CRUD operations, reading, writing, updating records. The main chunk of our learning was around GraphQL. Jordan's going to go into that in a bit more detail, but the power of GraphQL is really to build up more flexible queries and mutations, so have access to data from the backend, only data that is required and not everything as a dump. Similarly, when we're updating, we can have a bit more flexibility. It also comes with a testing tool, GraphQL, which has been really powerful, and I think the whole team have used it extensively, which is kind of self-documenting, and it allows team members to kind of see what currently is available on the API and how to interact with it. For further testing, we use Jest, which we already know, and Axios as well to get information from our TripAdvisor API for our restaurant data. So over to Jordan now to talk a bit more about GraphQL and some of its considerations.
Thanks, Christoph. So I'll talk about some of the challenges the team faced during the project. And our biggest initial challenge was actually learning GraphQL and getting to grips with how the schemas are built and how data is queried and mutated in GraphQL. And this is quite different to like the normal get and post request you make with a RESTful API, which is what we learned during the course. So it took us a bit of learning to get to grips with that. And we also found that error handling on the back end is different with GraphQL, as there's only one endpoint. And although GraphQL has some inbuilt error handling, it's not as easy to customize or control as what we found with the REST API. The other main challenge was integrating Firebase with our MongoDB database. Both Firebase and MongoDB automatically generate unique IDs, and we needed to link these throughout the app. We didn't foresee this being an issue during the spiking phase, and then we were then too far along in the project to change our database to say Firestore, which would have provided better integration, but thankfully we found a workaround in the end. The other other main challenge was the TripAdvisor API we were using, which is where we're getting the restaurant data from for the app. And this is a freemium version of the API, which had a limit on the number of API calls you could make on the account. I think it was 500, which we burned through pretty quick in the first week. And we also found some of the data coming back was inconsistent, like didn't have any description or photos of the restaurant, and so we had to get around this by applying some filtering at the back end to to remove those. And I'll lastly say, although we're the only Northcoders cohort which has been fully remote throughout the whole boot camp, so we were kind of used to remote working and the remote working environment, it did still have its kind of issues and challenges, like more on the technical side, like to do with data speeds and connection stuff. And we also had to deal with the odd barking dog and gnawing parrot and inquisitive child during our stand-ups and pair programming. So there were challenges there, but overall we were kind of used to it, and it worked pretty well. And which moves nicely onto kind of how we worked as a team. So I'll just kind of briefly explain that. So we used agile practices like daily stand-ups, and we had a virtual Kanban board using Trello. For the stand-ups we used Discord, and we had our own channel in Discord, and we probably had 2, if not 3 stand-ups a day. We did a lot of pair and mob programming using Discord and VS Code live share together. And then we also used Git for version control as well, which worked really well. And in the initial start, like the planning stage of the project, we used Xmind for like flow charts and mind maps as well. And overall, the team worked really well together. So now I'll pass you on to Lee, who's going to just finish up and give a roundup.
Thanks, Jordan. We are very proud of what we have achieved and created in just 2 weeks. A team working fully remotely who have never met each other before have come together as a great unit, and with a great example for remote working in this modern age. We see an abundance of opportunities for this app, greater customization for the user via dietary requirements, price brackets, and monetization for businesses to connect businesses to consumers through tech like Sockets.io to create a live messenger service. Thanks for taking the time to view our app and our presentation. We welcome any questions in the live chat below. All that remains is for us to finally meet as a group, if only we can ever decide on where to eat.